Hello everybody. Today we're going to be doing a video for Chapter 3, Lesson 5. We're going to talk about another way to graph a line, a linear equation. So far we've talked about graphing with a table and starting at the y-intercept and using the slope. Today we're going to introduce a new way, and that is using both intercepts. Okay, so not only the y-intercept, but the x-intercept as well. So first, what is the x-intercept? The x-intercept, much like the y-intercept, is where the graph of the line will cross the x-axis. So since a linear equation can be graphed using 2 points, you can use the x and y-intercept to graph an equation. So if we take a look at example number 1 here, I'll show you how to do that. So it says state the x and y intercepts of y equals 1.5x minus 9, then use the intercepts to graph the equation. So the first important thing to realize is that this is an equation that's written in slope-intercept form, which is y equals mx plus b. Okay, that's slope-intercept form. So I know right away my slope is 1.5, and my y-intercept, which is b, is negative 9. So my y-intercept is negative 9. And I know that just by looking at it, and that's half of my first answer. Okay, so my y-intercept is negative 9. The second part, in order to find the x-intercept, we have to think about what is an intercept. Okay, so if I go over to my graph to find negative 9 on the y-axis, because that's where my line will cross the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, right down here at the bottom. Okay, I can put the point here because I know that is where my line will cross my y-axis. Well, if I think about it, at that point, what is my x-coordinate? My x-coordinate is 0. So I could plug 0 in for x to find my y-intercept. 1.5 times 0 minus 9. Well, anything times 0 is 0. 0 minus 9. My y-intercept is a negative 9. Now, I don't really suggest doing that because I know immediately from the form of the equation that the y-intercept is negative 9. But the concept is exactly the same for the x-intercept. Along the x-axis, that's where my x-intercept is located. That is where my graph will cross the x-axis. Well, along that line, the y-coordinate for all of these points will be 0. So if I plug 0 in for y, I can find the x-intercept. So 0 equals 1.5x minus 9. So to solve for x, I need to add 9. I get 9 is equal to 1.5x divided by 1.5. And I get x equals 6. So my x-intercept is equal to 6. And you can abbreviate both the x and y-intercept as x and then sub int for intercept. So I've already graphed over here my y-intercept at negative 9. My x-intercept then, I just need to go over to 6 on the x-axis. 1, 2, 3, 4, 5, 6. Put a point there. Now I have my required 2 points to draw a line. Take out my handy dandy ruler, and that is the graph of that line. So in summary, in order to find the x and y intercepts, you can plug 0 in for the opposite. So to find the y-intercept, plug 0 in for x. To find the x-intercept, plug 0 in for y. So if we take a look at the next page here, you can go ahead and pause the video and try these on your own. So pause the video and I'll be back to explain these in a second. Alright, you should be back from trying A and B on your own. So if we look at A first, right away we know it's in y equals mx plus b form or slope-intercept form. So I know my y-intercept right away is 5. Okay. In order to find my x-intercept, all I need to do is plug in 0 for y. So let's see, I'll do that over here. 0 equals negative 1/3 x plus 5. So to get x by itself, subtract 5 from both sides. I get negative 5 is equal to negative 1/3 x. Now, in order to get rid of a fraction that is attached to my variable, I need to multiply by the reciprocal. Well, the reciprocal of negative 1/3 is negative 3 over 1, which is just negative 3. So I multiply both sides by negative 3. This cancels. I'm left with 15 is equal to x. So that tells me my x-intercept is 15. Okay, x-intercept is 15. So, again, to graph these, all you have to do is plot both the x and y-intercept and draw your line. My y-intercept is at 5. I look along my y-axis here. I'm going by 2s. 2, 4, 5 will be right in between there. And then my x-intercept is 15. Again, 2, 4, 6, 8, 10, 12, 14, 16. So 15 will be right in between there. And there's my 2 points. Put my ruler down and draw my line through them. That is the graph of that equation. Moving on to B. B works in much the same way. Right away from the form, I can tell that my y-intercept is 3. My x-intercept, all I need to do is plug in 0 for y and solve for x to figure that out. So 0 equals negative 3 over 2x plus 3. To get x by itself, I subtract 3 from both sides. Negative 3 is equal to negative 3 over 2x. Multiply by the reciprocal. So I multiply by 2 over negative 3. Multiply by 2 over negative 3. On the right side, everything cancels, and I'm just left with x. On the left side, the negative 3 on the bottom and the negative 3 on the top cancel, and I get x to equal 2, which means my x-intercept is 2. So again, in order to graph this line, all I need to do is plot both of these intercepts in the right spot and connect them. Y-intercept is 3, right there. X-intercept is 2, right there. Draw my line. And there you have it. So moving on to the second half of the lesson here today, we're going to talk about something called standard form. Standard form is another form of a linear equation. So far we've had slope-intercept form, which is y equals mx plus b. Here we have standard form, which is ax plus by equals c, where a has to be greater than or equal to 0, and a, b, and c are integers, which means they're not fractions and they're not decimals. So a has to be greater than or equal to 0, which means it is positive, and a, b, and c cannot be fractions or decimals. One of the things about standard form is it really helps us in terms of making equations from word problems, because a lot of word problems are set up in kind of the standard form layout. So that can definitely help us when we're working with word problems. So if we take a look at example number 2 and 3 here, it says Malden Middle School wants to make $4,740 from yearbooks. Print yearbooks, which are X, cost $60, and digital yearbooks Y cost $15. This can be represented by the equation 60X plus 15Y equals $4,740. So what they're doing is taking the amount of books, which is print yearbooks, which is X, multiplying it by the cost to get the total amount of money they make from print yearbooks. They're going to add that to the total amount of money they make from digital yearbooks, which is Y, the number of yearbooks, times the cost, which is 15. So here it says use the X and Y intercepts to graph the equation. So if we start with 60X plus 15, Y is equal to 4,740. Okay, again, in order to find the x-intercept, I plug in 0 for y. And in order to find the y-intercept, I plug in 0 for x. So one thing that can help speed this process up rather than plugging it in is something called the cover-up method. It's called the cover-up method because, for example, if I'm trying to find the x-intercept, I'm going to plug 0 in for y. Well, 15 times 0 is 0. So then 60x plus 0 is just like covering this entire term up and making it go away. So I can stick my thumb over there. So to find the x-intercept, I solve the equation 60x is equal to 4740. Because plugging 0 in for y is essentially taking that out of the equation. So I really have 60x equals 4740. If I divide both sides by 60, I get x to be 79. So my x-intercept is 79. Okay. The same way I can find my y-intercept. So to find your y-intercept, you plug 0 in for x. Well, if I plug 0 in for x, it's essentially covering that up. So really what I have is the equation 15y equals 4,740. And I divide both sides by 15 to get my y-intercept to be 316. So in order to graph this equation, now we have some bigger numbers, so we need to figure out something we can go by on the x and y axis. We need to figure out an interval. It looks like on the x-axis we could go by tens, 20, 30, 40, 50, 60, 70, 80, 90, and x was again the print yearbooks. And on the y-axis, maybe go by 50s might get us there. Yeah, it should. 50, 100, 150. And 400. And these were the digital. So now, example number 3 is a very important question here. It says interpret the x and y intercept. So first, let me graph these. The x-intercept was 79, just about 80, and then the y-intercept was 316, just a little bit over 300. And now I'm only going to connect these lines because it's a real-life situation. I'm not going to extend them on through because if I were to extend this on through where y is negative, well, you can't have a number of negative digital yearbooks, and I can't extend it on this direction either because then you would have negative print yearbooks, and that's just not possible. So I'm only going to connect my two dots. Now, example number 3 says interpret the x and y intercepts. So really you have to understand what x and y stand for. X stands for the number of print yearbooks, and y stands for the number of digital yearbooks. So at the x-intercept, okay, the x-intercept, I have the ordered pair. This point right here is 79, 0. Okay, so what that means is my x-coordinate is 79 and my y-coordinate is 0. So what that represents in terms of our situation is 79 print yearbooks and 0 digital. So that represents one combination of print and digital yearbooks that get us to this $4,740. Okay, this would be, for example, if we sold 0 digital yearbooks, we would need to sell 79 print yearbooks in order to get us to our goal. And the y-intercept is the exact opposite. So the coordinates of that point are 0, 316. So that means I have 0 print and 316 digital. Okay, x and y. So if I have 316 digital, so that would be a scenario where I sold no print yearbooks. Okay, then I would need to sell 316 digital yearbooks in order to get me to this 4,740. So really what this line represents are all the different combinations of print and digital yearbooks that get me to this $4,740. Okay, so how this is helpful is that we can take a look at this line and say we need an ordered pair above this line in some direction to make more money than that. Okay, so for example, if we sold 40 print yearbooks, we would need to sell at least, it looks like, about 150 or a little bit over 150 yearbooks or digital yearbooks in order to make our money. Okay, so this is extremely helpful in terms of business and finance, and even in terms of a middle school fundraiser. So if we take a look at the Got It section problem, okay, go ahead and pause the video. Try this one on your own based on the last one, and I'll be back in a second to go through it with you. Okay, you should be back from trying this one on your own. It says Mr. Davies spent $230 on lunch for his class. Sandwiches, which are X, cost $6, and drinks, which are Y, cost $2. This can be represented by the equation 6x plus 2y equals 230. Use the x and y intercepts to graph the equation, then interpret the intercepts. So first we need to find our x and y intercept, and again, to do that we're going to use the cover-up method. So 6x plus 2y equals 230. In order to find the x-intercept, I cover up the y term, and I'm left with 6x is equal to 230. So I solve this equation to find my x-intercept. So I divide by 6 on both sides, and I get x to equal 230 divided by 6, 38 and 1/3. Okay. Likewise, I use the same process to find my y-intercept. So I cover up the x term, and I'm left with 2y is equal to 230. So I divide both sides by 2, and I get y to equal 115. So my y-intercept is 115. My x-intercept is 38 1/3. So in order to graph these, I just plot them on the x and y axis respectively. So x-intercept 38 1/3 should be probably about right in there. Okay, my y-intercept is 115. Looks like probably right about there. Okay, and again, when you're dealing with larger numbers like this, that's an estimate. Can I guarantee that's exactly at 115? No, but it's a pretty good guess. So again, in a real life situation, we want to only connect our dots because we can't have negative drinks and we can't have negative sandwiches. Okay, that doesn't make sense in our situation, so we're not going to graph it. So again, here we want to interpret the x and y intercepts. So my x-intercept is 38 1/3. X represents the sandwiches. So that would be one combination of sandwiches and drinks that cost $230. So for $230, if I only bought sandwiches, I could buy 38 1/3 of them. Okay, so that's what our x-intercept represents, where if we only bought sandwiches, that's how many we could buy. On the opposite end, our y-intercept, if I only bought drinks, I could buy 115 drinks. Okay, so that's what my y-intercept represents. If I bought 0 sandwiches and only drinks, I could buy 115 of them with the $230. And again, every ordered pair along this line represents a combination of drinks and sandwiches. So for example, this one looks like it's pretty close to 25, 40. That would mean for $230 I could buy 25 sandwiches and 40 drinks, and that's one combination. And each one of these represent a combination that equals $230. So in addition to the lesson here, I have a couple extra practice ones that I want to go through to make sure we really understand how to do this. So for number 1 here, I have y equals 3x minus 9. Again, I want to state the x and y intercepts and then graph them. Okay, so right away it's in slope-intercept form. Y equals mx plus b. I know b is the variable for the y-intercept, so I know my y-intercept right away is -9. In order to find my x-intercept, I plug in 0 for y, and I solve. So 0 equals 3x minus 9. Add 9 to both sides. 9 equals 3x, divide by 3. My x-intercept is equal to 3. So in order to graph this, all I do is plot both points and connect them. X-intercept is 3, y-intercept is -9. This is not a real-life situation. This is just a mathematical problem, so I can go ahead and make my standard line with arrows on both sides, and that is my line. So then for problem number 2, works almost exactly the same way. Y-intercept, since it's written in slope-intercept form, is 2. My x-intercept, in order to find that, I plug 0 in for y, and I get 0 equals 1/2 x plus 2, minus 2, minus 2. So -2 equals 1/2 x. In order to get rid of a fraction that's multiplied by my variable, I multiply by the reciprocal, which is 2. And I end up at -4 is equal to x, and that is my x-intercept. So I plot my y-intercept, 1, 2 on the y-axis, my x-intercept on the x-axis, 1, 2, 3, 4, and I draw my line through those 2 points. So again, this is a different way to graph your linear equations that some find a little bit easier than the other way, but both are valid. So it's another choice for you in order to see which method you like best. But if it says use the x and y intercepts to graph, you need to use the x and y intercepts to graph. Okay. So with that, here is the assignment. I'll turn my filter off so you can see the colors. Go ahead and choose the assignment that is best for you, red, yellow, or green. Alrighty, thank you.